Welcome to Elemental Fun, a historical and cultural look of the elements of the periodic table. Hello and welcome to Elemental Fun. My name is Grace.
My name is Cindy.
We are recording to you from the snowpocalypse of the Pacific Northwest.
Dun, dun, dun.
There's 3 inches of snow outside.
And ice.
Yes.
It is just quite a bit icy. So there's that.
Goodness.
That's part that's really more.
Okay.
But still, I know. No, it's ridiculous.
I'm from
Florida.
Okay.
And I still say this is ridiculous.
I'm from Eastern Washington. I'm going to lead the survivors out of this, if there are any.
Because there'll be any. Although they all stocked up at the store.
The grocery stores are empty. Sorry. I had to vent a little bit. We're not talking anything about ice or snow. No, we're going to talk about 2 metals that no one really knows or cares about.
Yeah. It's true. Their names are Osmium and Iridium. So which one should we talk about first?
They're 2 very dense, literally, buddies that are found in nature together a lot. I think we should talk about osmium first.
Okay, well, let's do, because they're both found the same way, so we'll start off with the history. So,
we can hit 2 birds, 1 stone.
Exactly.
Or 2
metal birds?
2 compounds.
2 compounds with 1 stone. In 1803, Smithson Tennant was the one that found it, basically. It was platinum, and he diluted it with aqua regia?
Yep.
Which is nitric and hydrochloric acids. And then not all the metal went into solution, and basically he found those 2 metals. Like, they thought it was graphite.
Yes.
Yeah.
Earlier chemists were like, that's just graphite.
Nope. He's like, I think not, sirs.
Yeah, because there's actually 2 different chemicals left in there. One of them was super smelly, and so he named it osmium.
It's Greek osmi is smell.
Yeah. It's actually not the actual osmium that is smelly. It is like its reaction.
Right.
So, yeah, it's the oxide.
Gave off a smell.
Yeah, it's not actually the metal. And then iridium got its name because it had a rainbow hue.
And again, not iridium itself.
Right.
But the compounds.
I know.
The salts. Those salts. So they were named after the Greek goddess of the rainbow.
Iris.
So if you want to be, which one you want to be? I would want to be iridium.
You want to be the pretty one?
The rainbow, not the smell.
You're dense either way.
That's true.
You're kind of the
Hey, wait a minute. What are you trying to say?
That you're pretty.
Oh, thanks. Talk about density, though. So these are the these guys are dense.
They are really
super dense.
They can't actually decide which one is more dense because they're found so often together, but they're kind of tied for gold.
Technically, because technically, osmium is.
Yeah.
And when you do that, but if you look at iridium, it says that it's the second density if you're just talking about just the measurement of density, which is mass per unit volume. But if you calculate it using space lattices, which I don't know what those are, but it sound awesome, then that one shows that iridium is actually denser. So it depends on how you measure the density that puts them, but basically they're both right up there. They're tied for gold, like you said.
Yes. And here are 2 elements that are usually found in platinum or in a compound.
Yes.
Not in platinum.
Silly.
They're super rare. In fact, iridium is considered
super rare. It's like the rare one of the rarest.
One of the rarest elements on the planet. I was listening to a podcast about osmium, and that, like, it's so very little. I can't think of the word. Not ored, but like.
Oh, it's hard to get it to find it.
They don't use it very much.
Right.
Like every year they like basically the industry of osmium's like about the weight of a tiger. Like the amount that they
can get out of it.
Well, that they use.
Yeah.
Even.
Well, because both of them they're found, they get commercially from nickel refining.
Right.
Both of them. So it's like the waste product of the refinement of nickel, and you get some of this other stuff.
Yeah.
Sweet. So the density, they're twice as dense as lead, right? So
Yes,
that's what everybody
yes,
thinks, like lead
yes.
is like, well, that's super dense. Yeah, nope,
nope.
nope.
Yep,
These guys
they're
are
both
ridiculous.
twice as dense as lead.
Mm-hmm.
So it has so it was once sought after osmium because it's it has a really high melting point of 3,000 degrees Celsius, which is 5,432 degrees Fahrenheit.
It has the highest melting point.
Yeah.
Mm-hmm.
So like these guys are tough.
Yeah.
And actually it's probably because they're space chemicals. Space, not chemicals, elements.
For the found. Oh yeah. So they actually, they found for iridium that there's a thin layer in the Earth's crust, and it's spread by everywhere. And they think that's from the large meteor that hit the Earth, and it spread everywhere. Probably the same one that killed the dinosaurs.
Yes, and the Yucatan Peninsula. I have that note.
Yeah,
we'll go back to that one in a second. But yeah, a lot of it they think comes from space. Doesn't come from because it's found like in pockets in our Earth's crust and not really anywhere else.
And in the core, some in the core, but yeah.
But is it in the core?
That's what they said about iridium.
But they don't know if it's in the core because we haven't been to the core. I hate when scientists are like, it's in the core. You're like, really?
Well, they have a lot of cool chemical sciencey thingies. Yes.
Prove it.
I'm sure they do.
Prove it, Cindy.
They prove. They have some other fancy stuff to do. Not to Grace.
Not to me. I need proof.
But didn't, what's his name, go to the center of the Earth?
Jules Verne?
Yeah.
Sure did.
There were dinosaurs there.
So did The Rock Johnson in that movie.
Yeah, and no, but who was the one before The Rock? Brendan Fraser. Oh, he went. Yeah.
And then they replaced him with Dwayne The Rock Johnson.
I'll take both of them. I like them both.
Yeah, I like them both
awesome.
Too. So
do you want to get used to the
osmium?
uses?
Osmium, yeah, it was so osmium by itself is not really toxic, but in its
oxide,
in the tetraoxide form. So they used it as for fingerprint detection.
Yeah, and the stain fat tissues for microscopes.
Yeah. But it's highly toxic.
Yeah, I know. This is really good. Let's put it on your fingertips.
No, but it's fingerprint detection. So wouldn't it be
right? But see, that's what I'm saying. Like, if they're doing that, like putting the powder on, but then you might inhale it, and it's super
then
bad.
You're creating a powder in the air.
Right. It's the oxide is volatile and very toxic, causing lung, skin, and eye damage.
Yes.
So it's like, here, let's dust the room for prints.
So they did that at first. Oh,
That's
also, osmium is very corrosion resistant.
Yes. Only iridium is more corrosion resistant. Yes.
Like they're basically twinsies.
Yeah, they pretty much are. They're really dense and they're not corrosive.
Just one is smelly and one is pretty, but not really them on their own. But
and the biggest thing that they use them for is the they basically are, because they're so dense, they're used for very hard alloys, so mixing with other metals. And I think the funniest thing is like the biggest thing for both of these guys is fountain pen tips.
Yes. Yes.
That's your claim to fame is fountain pen tips.
But they also use
compass bearing.
osmium in like phonograph needles as well. Something that uses a lot of wear, like the fountain pen.
Right.
So something that is going to be like over and over again scraped on something.
Yeah, it's going to be resistant to that.
They also use osmium in pacemakers and heart valves.
Yep, surgical implants.
Yeah, which I'm like, wait, it must not be an oxide version.
No, just the actual osmium.
But they obviously can't put too much of it because it's so dense.
Right, because the implants would be super heavy.
Yeah.
Well, again, they're making alloys, so they're making the metal that they're using in it more durable,
right?
Without putting that much weight to it, because the alloy is much less.
Yes, it's when alloyed. The medical implants is when alloyed with other metals in the platinum group.
Yes, and the
platinum. I'm like looking at the word. I even wrote platinum in this like way, so I couldn't.
Yeah, because the platinum group is ruthenium, rhodium, palladium, iridium, and platinum. And osmium, I guess that's in there too. Yeah, and osmium. I was like, wait a minute, that's in the. Oh yeah, and osmium. Yeah, they also use it in instrument pivots and then needles and electrical contacts because again, something that's has no it's a low reactivity. So you want something.
But it's also used as a catalyst in the chemical industry as well.
Yeah. So do you remember what a catalyst is?
No.
All right then.
Listener, do you remember what a catalyst is?
No.
It's the catalyst
thing. So remember, catalyst speeds reactions.
Right.
Speeds up reactions. So I don't know exactly what it does. Right. Catalyst usually is either helps bring the two things that you're trying to get to react together, makes it easier for them to get together or whatnot. Kind of like the online dating for dating, right? It's like, oh, I'm going to try to find you somewhere. No, you can just all go to this one place and everybody can find each other, kind of thing. But there's maybe other things that it can do as a catalyst as well.
I'm going to go off course for a second. Did you hear that Samsung has a new dating app out where you take a picture of the inside of your fridge, and that's your dating profile?
Really?
And so you like swipe left. I'm like
kind of
ooh, that
awful,
person
but
has
brilliant.
quinoa and kale in their fridge. That's my style.
that.
Or like leftover pizza, swipe left.
Yeah.
Except I actually don't know if you swipe left or right. I don't know because
I've never done those apps.
Yeah, apps didn't exist when last time I was dating.
I did online dating, but there was no apps yet.
Right.
Yeah.
Yeah, I didn't at all.
Yeah, I think it's swipe. I think right is you like it, and left is as you don't.
I think it's the other way.
I don't know. But then I saw a TV show, and they had a
readers, please, readers, listen. Oh my gosh,
there's readers.
If you are listening or reading this,
if you're reading this, I don't know what's wrong.
Then you're magic. Listeners, do you swipe left or right if you like someone's inside of their fridge?
On this Samsung dating
Let
app,
us know.
apparently.
It's called like Refrigerdate or something.
That's awesome.
It's pretty funny. Anyways, I'm gonna stop talking about online dating, and talk about the Osmium. Actually, part of its name is in one of the biggest light bulb companies in lighting manufacturers in the world.
What's that?
It's Osram.
Osram. Never heard of.
Well, they're huge.
You are so out of it.
Basically, you don't know about
You don't know
Osram, the German lighting manufacturing company.
Come on.
So basically, what happened was, a long time ago, osmium was more sought after because after Edison's light bulb, and it worked, and he needed it. They were looking for a filament, which is the little metal thing that gets really hot.
Right.
So they're looking for a metal that can handle getting that hot.
Okay, right. Which
And
this one would be
without burning out or without, melting. So they because I guess Edison used a bamboo at first.
Oh.
I don't know how that worked without just catching on
fire.
fire. But
Sure.
I was listening to this guy and he's like, "Really, Edison? Really? Bamboo?
Fire.
Really?
Wood. Yes. Light."
Like, what?" So they were using osmium. They're also using tungsten.
Okay, yeah. Well, that's
Those were the top.
Yeah,
those were the top. And tungsten has kind of won out because it's easier to extract tungsten than it is to extract osmium, and tungsten's more abundant. So there was a German company, Osram. It was created because they took the OS from osmium, and then tungsten in German is Wolfram, and so they took the RAM, Osram.
I see what you did there.
Yeah, well, I know I did it.
I see what they did there.
So its name is involved in one of the largest lighting manufacturers in the world that I didn't know existed, but apparently it's very big.
Very big.
So thank you, Osmium.
Awesome.
Even though I'm pretty sure you're not even used for that anymore. They're like, yeah, we can use osmium.
we do
Just
that
kidding.
thing.
We're going to use
Yeah.
tungsten or Wolfram.
Or something else that's easier to find.
Yeah.
Because they do find it, you can find it just as osmium in nature, or as the mineral osmiridium, which is an alloy with iridium. Those are
Because
they're right next to each other on the periodic table.
They just hang
they're
out.
both- Yeah.
They're buddies.
And they're both shiny silvery, but osmium is like a bluish white.
Yes.
Yes.
Yes, it is.
smelly.
And smelly.
And smelly. It's true.
That's all I have on osmium.
Yeah, osmium's really not. I mean, the biggest part that's difference between iridium and osmium is the fact that any type of, there is a type of osmium that is toxic, right? Which is those tetroxides.
Yes.
But iridium doesn't really have.
It doesn't
that
really do
problem.
that.
Yeah. But it's interesting that that those osmium tetraoxides for the fingerprints, but then that the fat tissue, because when you do under microscopes, all our cells are generally translucent, so you can't actually see them. So they have to stain it with something. So if you've ever had a biology class where you've got to scrape your cheek cells and put them on a slide and look at them, usually use some kind of dye like methylene blue or crystal violet to stain the outside of the membranes and the nucleus so you can actually see it. So, and fat cells are just giant blobs of fat, basically. It looks like there's nothing in it because it's translucent fat. So it's kind of interesting that they would use that. I don't know why they specifically used that one versus other stains, but some stains work better for certain cell types than others.
Yeah.
So, interesting. Yeah. Interesting. Yeah. So,
one more thing about osmium.
Oh, osmium. Yes.
I just read my note. Boop. Osmium, actually, the osmium tetraoxide was it was the center of a terrorist alarm in London in 2004.
Really?
Yeah. But apparently there was like
they have tetraoxide.
They probably someone probably just dropped that powdered form. And they were like, unknown, and it was probably causing some reaction to people. And
so they thought it was like anthrax or something crazy.
But it was just osmium tetraoxide.
Interesting.
So, yeah, that's. I mean, really, these guys, these two metals are. I mean, they're cool, but
they're cool. They're not really like.
There's just really not much to them.
Which, I mean, we're gonna get to some of those.
We're gonna get to a lot
of those where it's like, well, there's this about it, and that's it. And next element.
I was basically looking at our periodic table, and I'm like, there's some elements that there's gonna be some boring episodes. We better hype it up a little bit.
I think next week, our next episodes, we'll have to do with the rest of the platinum group. So there's probably going to be 3 or 4. It's like blah 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 blah. Hey, platinum. Let's talk about that one.
Platinum will be fun.
That will be a good one.
It's so shiny.
Okay. So if you just want to make a guess, then we have the top 3 reserve holders of osmium. Ooh, 3 countries. Where do you think?
I saw 2. I saw 2 of them on your notes, and I don't know which one was the top, though.
All right, we'll do guess which one.
South Africa.
That is the top one.
Yeah.
They have the most, and then Russia, and then USA. What? The bronze. Yeah. So apparently we've got the 3rd highest amount of osmium. That's something to brag
probably because other countries were like, I don't care.
Right. This is a stupid thing to try to get. So
like,
okay.
I don't. Yeah.
Again,
not really worth it. So iridium.
Right, iridium.
Okay.
So yeah, this is a silvery metal or white yellowish hue, almost as unreactive as gold, which is why it's used in some stuff. The salts are highly colored. So again, the salt. To go back to chemistry, the salt is an ionic compound. So bonding between a metal and a non-metal.
Right.
Basically, it's in general, and it is very hard and very brittle and very dense. And the most corrosion-resistant metal known to man.
Yes, and it therefore was used to set the international standard weight of the kilogram in 1884.
Right. And that one is still actually used. So there was also before 1960 because of the due to the fact that it doesn't corrode. It was used to set the standards and weights and measures. And including the meter, but that one has since been replaced in 1960s, and we talked about this on our krypton episode about the orange-red spectral line of krypton that is now the standard for that. But the kilogram one is still used today.
Good job, iridium. You did something right.
You're doing something right.
You may be dense, but you set a standard, man.
So, and talking about the melting point, or the thing, you have to heat it to 2200 to 2700 degrees Fahrenheit to work it. So because of that,
it's actually used in crucibles.
Right. So that's why, because those things that have to have high temperature.
Yeah.
Or withstand it.
Yep. Yeah. They're also used to start cars. Conducts the spark.
Oh right, yeah, the spark. Yeah, because the contacts and spark plugs where you want something to not react, except for have the spark go.
Right.
Yeah.
And they can
and the high melting point.
It can last about 80,000 miles. That spark.
That's pretty good. Oh wow, that's impressive.
Well,
like I said, it's got that low reactivity and high melting point.
I kind of really want a pen now with iridium in the fountain pen tip.
That'd be pretty cool.
Yeah. They also, like you said, compass bearings, crucibles, and a hardening agent, probably with other.
Yeah. Well, again, it's like osmium.
It's like its buddy.
It's like right there. Yeah, and the standard meter bar that we're using is 90% platinum and 10% iridium. But yeah, I'm basically making those really strong alloys. Do you know that the radioactive isotopes are used in radiation therapy?
Huh.
Yeah.
I didn't know that.
Mm-hmm.
They're trying. I feel like scientists are like, I gotta find a use for this.
These guys gotta be good for something.
Have a purpose, even though it's super rare. Why am I trying to find it?
Right.
So yeah, no, you're talking about the meteorite that they believe was the extinction of the dinosaurs.
Right.
In 1979, it's the Chicxulub meteorite.
Okay.
It was filled with iridium.
Mm-hmm.
And it's the meteorite that hit the Yucatan Peninsula 65 million years ago and is believed to be the one that caused the extinction of the dinosaurs. So, Iridium, you ruined my dream of having a pet dinosaur.
Good job,
Thanks
Iridium.
A lot. Yes, shiny rainbow rock.
I thought you were going to say something else. Shiny.
I'm trying to keep this a clean podcast.
Clean podcast. We're doing pretty good so far.
Actually, yeah.
We are. Yeah. It's pretty good for us.
Surprisingly so.
Surprisingly good.
Yeah.
It's the primary metal used to harden platinum to get alloys out of that. I was going to say something else. Oh, optical lenses to reduce the glare. It's used in those as well. Yeah. Super strong jewelry is iridium and platinum alloy.
Again, it hardens things.
Mm-hmm. It's very hard.
You know, I tried to look up in the periodic tables, and both of these elements are mentioned like twice.
Because like this one, it's very rare. It's one of the rarest elements. It's found in sediments deposited by rivers in its uncombined state. But then you get it from nickel refining and copper refining actually for this one.
Yeah.
But yeah, like there's nothing like
they're there. Well, in periodic tales, like one of the things was because the little tidbit about the terrorist alarm in London. Basically, what happens was the author was talking to a guy who like tries to collect elements in their pure form he wants to create his own periodic table.
I reading about. I did read that part of
it.
You did? Yeah, I did. When he wants to get, he's trying to get a piece of every little thing.
And osmium was one of those ones that he was talking to a guy, and it's really hard to get just like a solid, pure sample of it. And I guess this chemist he was talking to, he gets like visits from like basically like the center of like nuclear and volatile substance board. People are like, they're like, hey, Bomb. So you ordered plutonium again, did you? Like, and so like osmium.
He's on a list.
Yeah. So osmium and iridium are some of those ones that's kind of like a little hard to get. That.
Yeah, I can see that.
It's kind of hard to get a pure
sample
of it.
If you're really trying to get that, why are you trying to get it?
Yeah. But then I guess the people are getting really friendly with that chemist, like the people that always are checking on him. They're like, here's a better way to hold that chemical so that you don't have an accident.
Right.
And like the idea of having a periodic table with samples of each of them
is really cool.
It's really cool. However, there's some elements I don't want in its pure form in my house.
No.
And then like I still don't understand like
probably
gases.
Doesn't have kids.
He does though.
Oh.
Remember he has a son?
Oh, yeah.
You're like, yeah, I don't remember that.
I don't.
Well, I was listening to our episode on lead and how they poured the lead in the water.
Oh, right.
And how like his son, he like poured it too fast. And it was just like a blob of lead in the bottom. So that's the only reason why I remember he had a son.
See, throw me under the bus.
Yeah, I go back and I listen to our episodes.
Oh. I do a little bit.
Should have seen the look she just gave me. Oh.
Making me feel bad.
Well, I think that's your own guilt. I also have a very long commute.
That's true.
And I think we're hilarious.
I do think we're hilarious too, but I just forget.
Especially since some of our old podcasts, it was
like a year
we
ago.
recorded them so long ago. I'm like, I don't remember that. I was like,
that's funny.
I'm so funny.
I like it.
Our banter is fantastic.
It's good.
Yeah. Good. So yeah. So that's. I mean, he really. And then he also talked about how Smithson Tennant, like he had discovered it, but then he was told like not to say anything.
Oh.
So it was talking about him,
Right.
and then so like osmium and iridium like came up.
Right.
But like, I mean, he wrote a giant book about the periodic table,
And there's like,
and like, I had to look through the page and be like, osmium. There it is.
don't you wish you could have Control F?
Is that?
Let's control like on your. If you want to find a word, you can be like Control F, and it's find, and it comes up, and you can search your document for the word.
I didn't know you could do that.
Did not you?
No.
Yeah. If you're like a Word document, like where or a PDF, like where was that word? You go Control F, and you type in the word you want to find, and it finds all the words.
If I learned anything from this podcast, is that.
So you just can't do that in books because they don't have the keyboard.
Where's my keyboard?
Gosh, dang it.
Where's my mouse?
I can't do it.
Keypad.
But on Tenet, though, I mean, good on him because he's a good example of science working how it should, where he found something and they're like, no, it's that thing. And like, no, I don't. Like maybe he didn't have any good reason to think that that was. Maybe there wasn't some. Sometimes there's like, oh no, that's something weird. I'm gonna look into that. Mm-hmm. Sometimes it's just like, I don't think it is. So I'm gonna do some more experiments, and then he ended up finding the new elements. So two
new elements.
Exactly.
That really look a lot alike. So the fact that he was able to differentiate them.
Yeah.
Well, except the fact that one of them smelled.
Well, that's true.
The other one was
pretty. Pretty. Well, again, but not by themselves.
Yeah.
Like the iridium has to do with the salts to be colorful. Mm-hmm. And then
the osmium is just in a reaction.
So do you know that they have on the Royal Society for Chemists website one, they have the symbol for each element. Yeah. The symbol for iridium is the dragonfly wings.
Yeah.
Because of the
I know
iridescent.
I know.
Isn't that where the word comes from?
I see that. Yes. I did know that. Iris.
No, I was just making sure because sometimes they're not. I was like iridescent. That comes from iridium, right?
Yeah. Well, iridescent, iridium, iris.
Yeah.
Greek.
Same thing.
Word for rainbow.
Right.
Yeah. No, I see that when I go on the app of the Royal Society of Chemistry, and I'm like, why do they have all these different symbols? And
I normally just go past them.
Yeah, because I'm like, that's a silly symbol.
But that one I was like, ooh, dragonfly. I was just gonna look up the osmium one real quick.
Okay.
If my phone would like to actually work there, it's a little slow.
Might not.
A little bit.
So, yeah. And you know what? This podcast was about. It's gonna be about 30 minits.
Yeah, that's what we originally.
It is a fountain pen.
It is. No, but that's not the. Is that the thing?
It might be.
Is it? Oh. Was it history or uses and properties that has that? I think it's history. There you go.
Yeah. Nope.
No.
I don't think it even has it. It's like
no, it does it. There you go. No, it's down here. Visual elements. Yeah, it's the fountain. The pen nibs.
The pen nibs.
I like that. I like that better than fountain pens.
It's the nibs.
Yeah, the visual elements image is the nibs of the fountain pens.
Yeah.
So back in the day, it was really important when you had fountain pens.
Yeah, and before they, really figured out tungsten's a better element.
Yeah, for light, yeah.
Yeah. So
you imagine how bad it would have been though if that was the only thing that they could be able to use was osmium, and we would not have gotten anywhere. We would not
have light bulbs.
No, that was my dog shaking his collar.
Both dogs came and joined us
because they were like, "Hey."
They're like, "What's up, guys?"
But yeah, we've been stuck in the literal dark ages.
Literal dark.
Little dark.
All right. Well, I think we should.
That's all we've got for them because there's
pretty much
else to
short
say.
and sweet. So, if you have any questions, comments, concerns, feel free to email us at elementalfunpodcast@gmail.com. You can follow my journey through parenting and running and science and my silly Snapchat videos that I post through Instagram at RunMamaRun50x50. That's 50x50. And Cindy, who's more sciencey than me, you can follow her at
and Pacific Mammal Research or PACMAM, PACMAM, Facebook and Instagram.
Yeah. Make sure to like, share, subscribe, tell your friends
and your strangers,
and tell your strangers.
Yeah, your strangers.
I do tell everyone. I'm like, do you like science? I have a podcast.
I have a podcast for you.
So,
yes.
yeah.
And
I don't know what we're gonna. Like we said, we're probably gonna finish up the platinum.
Yeah, the platinum group next after this. Yeah, I think the rest of the platinum group and then platinum on its own. I would think. Mm-hmm. Because the other ones are probably like iridium and osmium, where they don't have that much to talk about.
We actually were just going to do osmium this time, and then we were starting to do research, and we're like, this is going to be a 10-minute episode.
Let's do a couple elements.
And then I was like, hey, you know what? Iridium was found together, and they're pretty much the same thing.
So we should do both. And voila.
And there you have it. Thank you so much for listening. And
what's your name?
Don't let the density get you down.
Don't be so dense. Don't be as dense.
Don't be dense. Don't be iridium. Keep learning. My name is Grace.
My name is Cindy.
Catch you on the flip side.
You're all like, blah, blah, blah.
I'm so sick. How are you surviving this snowpocalypse?
Snowpocalypse! We went sledding down the road, like down the hill. It's pretty awesome.
Yeah.
Yeah.
I didn't leave my house today except to get to your house.
Snowpocalypse means like 2 inches of snow.
Yeah.
Yeah. That's where we live.